My name is Revan. I am nobody particularly interesting, just a fan of the Plan 9 operating system and the people who built it. A few months ago, I started running a Plan 9 grid with a file server in the US, but I serve multiple people around the world in different regions. As you all know, 9P is a notoriously latency sensitive protocol. So it's pretty much common sense that you cannot really deploy a Plan 9 grid globally without suffering major performance penalties. I started a game studio a few months ago as well. It's structured in such a way that there are no managers and everybody is self-directed. And of course, I'm going to target Plan 9 as a platform. If this is something that interests you, feel free to talk to me or send me an email later. So when we design our networks on Plan 9, we typically make our file servers close to our CPU servers exactly because of the latency sensitive. Now, the server that I'm using is quite limited. It only has 512 megs of RAM. And the idea that I had was to use the terminals for connecting directly to the file servers and using them as CPU and memory for their users instead of having dedicated machines. Now, since modern computers are extremely fast, this is a feasible scenario. Now, I assume that if somebody were to deploy a Plan 9 grid globally, what they would do is they would have different separate installations of Plan 9 on different regions that they want to serve, and they would occasionally synchronize with the main file server with replica pull and push. I mean, if it's only you or if it's only a few servers, that's fine and manageable, but as soon as you add more people and you add more regions that you want to serve, it becomes exponentially harder to keep track of things in your grid. So this is why I started our project to be able to use file servers over very high latency links. If you are using multiple machines on your Plan 9 grid, this begs the question, what's the point of using Plan 9 if you have to keep separate installations if you want to access the same files remotely? So ideally, I should be able to connect to my server through anywhere I want, and if I want to compile syssource, I should be able to do so as if the server was local. This is, for example, if I try to boot this terminal right here using, let's say, a link that has 200 milliseconds of latency to my file server, it's going to take about 8 minutes to boot. But if I use the local disk on this ThinkPad, it's going to take about 10 seconds. So this project that I aim to create is meant to lower this gap so that it gets closer to the 10 seconds mark. But Plan 9 already comes with a cache file system. It's called CFS. If I use it on this terminal, I do see a performance improvement. It goes from 8 minutes to 6 minutes to boot. But it's still a miserable experience. It's still far from the goal of 10 seconds that I have. But then, why would CFS be so slow? Aren't the files already stored in disk and cache? Well, yes, they are, but before accessing each file, CFS still relays most operations like twalk, topen, twrite, and tstat to the file server. This means that even if you have the file cached in your disk, CFS still has to receive the rwalk and the ropen from the server. That alone on a 200 millisecond latency link is going to be 400 milliseconds. It also doesn't help that most of our tools perform file system operations linearly. Even if they need to work with multiple different files at the same time. But this is understandable. When we write C programs, we don't really expect open and read to take 200 milliseconds to complete. We expect them to go as fast as our computers allow, so we don't really take into consideration making these programs parallel. But even if we did consider that, if we were to adapt every single program from LS to MK to become highly parallel and create new procs for every file system operation that we wanted to make, it would add way more complexity than would be worth it, and we would have no benefits for it. So this is the Spanish Inquisition. Instead of a major user space refactor, I'd rather have the tools remain the same. So in order to achieve that, we need to change things on the 9P layer. But how exactly should we solve it? I'm not really fond of the idea of extending the protocol to solve a problem like this. Usually these things are reserved for when we really have no other options left, or we have run out of ideas, and I don't think that's the case. So a previous protocol, OP for the operating system Inferno, attempted to solve the same problem by merging multiple operations, twalk, topen, tread, and write, into two operations, tget and tput. It also didn't exactly change the 9P protocol because it created two programs to talk between the client and the server, which are OFS and OExport. Now, the protocol worked well. It reduced the round trip problem that 9P faces at the loss of FIDs, feeds, which has both its positives and negatives. But it still relied on the client's latency, on the client's link speed. If the latency was too high, the effects of this protocol would not be substantial enough to provide a reasonable experience. So even if solving the round trip problem is still not enough, the only solution left would be to reply to the client before the server replies to it. And that is what PFS is. Wait, what? Reply to the client before the server replies? This makes no sense. What are you talking about? Well, I know. Hear me out. What if the program keeps a copy of the file tree, let's say a shadow tree, and in memory with just the metadata and occasionally some data from a few files. And it replied to the client as fast as it could with the data that it had, but at the same time, it still forwarded every single request that the client sent to the server. Now, I know this sounds a little bit ridiculous at a first glance, but I guarantee you that if you think about it for a little bit more, and on a second glance, it's going to sound even more ridiculous. So let's step back for a little bit and use the and think about what the use case for PFS is. So essentially, PFS is trying to serve a file server across the globe to multiple different people. Now, if we want to do this without relying on the latency speed, of the link of the connection between the client and the server, we really have to cache the file system in it. But this provides some complications. If we are caching the file system, there's going to be some consistency problems between users operating on the same set of files. So, what sets of files are the ones that are most likely to be contentious among users? If we think about it, by default, on a default installation of Plan 9, a user really only has access to his home directory, his mailbox, and his cron directory. And this is by design. The user doesn't have access to syssource. He cannot perform changes on other places that are important to the system, because the idea is that it is assumed that the user can create his own namespace with his own programs. He doesn't need to ask for permission to install something. He can just download it, compile it, and run it without asking for the administrator for something. And he doesn't affect the other users. That's what Plan 9 was built for. That's essentially what the slide talks about. So the base file system is more of a template rather than the absolute truth of the system. Okay, so even if the users are technically contained in their own gardens, the system administrators are not. They can still perform file operations on a set of files that are even more, arguably more important than user files. So, but here's the thing. Even if these files are being done directly on a file server without a proxy, if two system administrators are performing changes without them knowing about these changes, they are still going to reach conflict. This is more of a coordination problem than a file system problem. So regardless if we have the proxy or not, it would still happen. In practice, most of the files a user interacts with are going to be private. So most inconsistencies are going to come from external changes like a sysadmin recompiling the system. At least this is the assumption that PFS makes. If you take it away, there's little motivation for you to continue this project. Now, you might disagree with it for reasons that are very valid, I'm pretty sure, but I think this is reasonable enough, so to be pursued. Now, if you look at the idea of keeping a shadow tree in memory, it kind of makes sense, as most of the tree will remain static anyway, and the most dynamic parts of it are going to be localized in the user's home directory. Now, from the client's perspective, it gets an immediate response. But in the background, the request is still being sent over the wire to the server. And since the server treats the response as authoritative, every single thing that the server sends to the proxy is going to update that cache with the latest version of what it has. But what if, whenever we walk to a file, we also read each directory of its path to scan for changes? This way, even access one binary like ls would already be enough to let the cache know that any files in the current directory or in the bin directory have been changed, which is very useful information for the shadow tree. Now, while this might sound wasteful, TCP actually likes this quite a lot. Compare it to sending one operation per round trip to sending multiple operations in one packet in the same TCP window. This has the same effect of this achieves a similar effect of the OP protocol of reducing the amount of round trips per operation due to the amount of caching that we are doing. And regardless if the request was initiated by the client or the proxy, all the server replies are going to update the cache anyway. So this essentially transforms a latency problem into a bandwidth one. And nowadays, bandwidth is pretty cheap and getting larger, so I think it's a pretty good compromise. Now, these ideas are very cool and help a lot with the file system consistency. However, they still do not guarantee that the cache will reply correctly to the client. For example, the cache might return an rwalk for a file that no longer exists. In this case, there's good news. Since we're sending all the requests to the server anyway, the cache will eventually know that this FID should not exist. So when that happens, it's simply going to poison the FID. And after that, every single request that the client tries to send over that FID is going to receive an error. It's eventually going to force the client to give up on that FID. So the more you use the system, the more accurate the cache is going to become. If PFS detects that something returned was wrong, it is going to poison it and move on. Okay, so let's talk about the elephant in the room here. What about synthetic file servers? How does PFS help with that? PFS does help, but not exactly directly. And the reason is 9P is a agnostic of whether the file is being served over a disk or if it is a synthetic file server. And typically when we have a solution for one type of file server, we inevitably end up breaking another one or making another one worse. And this is the case for PFS, but one assumption that we make is that if we improve the latency problem on a disk file server, this means that we no longer need a CPU file server to be close to the file server. So we can serve a CPU file server closer to the region that a person is at, or even at the terminal they are at. And for example, a file server like UPA's-FS or WikiFS, and it would act as if the files were local. So you get an improvements over synthetic file servers indirectly. Now, file servers like DevDraw, they wouldn't see much. They wouldn't see much benefit from PFS. Anyway, lastly, PFS should also be able to warm up its cache during boot. But right now, PFS is still very incomplete. It still doesn't have a memory limit. There are lots of bugs I need to fix, and it currently just caches a few operations. And the major one, tread, is not one of them. It doesn't store anything on disk yet, so there's no persistence. And but even if I am just replying with on cache with twalks and tclunks, I still see a 2 times improvement when I try to recursively list my home directory, for example. Now, you're going to have to trust me on this because I have not benchmarked before coming here. When I finish this program and I write the actual paper, you're going to see the actual benchmarks. So, but at least this is already an indicator to me that I'm doing something right, and it's worth pursuing. So overall, PFS doesn't really eliminate the latency between the client and the server, but it makes remote file servers usable over very high latency links. Now, some of these things I talked about are mostly ideas, which was usually when I get to implementation, I might change something or entirely drop it, which is why this was fitting to be a work in progress paper. And also because I didn't actually complete it. But anyway, my objective for this hackathon is going to be to complete this project and get to use it, daily drive it. And my code is available under this address, and that's it. Do you have any questions?
All right, thank you. And it looks like we already got some more questions again.
Hello, thank you for the talk. This addresses one of my pain points. Living on the other side of the world and trying to, RCPU with systems in Europe or something.
That's exactly
it's pretty bad. I'm slightly confused a little bit. It sounds what you talk about is clearly a client-server architecture here.
It's a proxy. It stays in the middle between the client and the server, in the middle.
Right, and at the beginning, you mentioned something about, or you were alluding at a distributed architecture, right? You
I am running a Plan 9 grid, and I distribute it across the world. That's what I.
Right, but if you have multiple file servers distributed across, and you're talking about coherence between all of the file servers.
Okay. So a typical solution for what we I assume if one of you were to make a global Plan 9 grid today. Right. I would assume that you would have multiple complete Plan 9 installations on the regions that you want to serve, but then you would have to use replica pull and push manually, and it gets exponentially more complicated the more regions and users you have.
Right. I mean, you run just face first into the CAP theorem, right?
I don't know what
the distributed database issue where you only have consistency, availability, or partition resistance.
I don't know what that is.
Any of those? Okay. I mean, so. It gets into the weeds. We can talk about it maybe over a drink or something. But that's a very well-researched, difficult problem that's different than this here, I think, right? So I'm just wondering if it sounds like you haven't really gone too much into the weeds on the distributed file system.
Well, I really don't know how to answer this question. The idea is pretty simple to me. We have a cache that's going to reply faster than the server can. It's going to predict answers basically, and I don't really see any
how do you? I mean, one question I have is how do you deal with the stale cache responses? Right. It sounds like you're kind of doing something like
Okay, so
a future. You're returning kind of a future or something because you can have a reply that's stale. But what do you?
So for example, I'm going to give you the example of the ls command. Let me go back a few slides here. So for example, let's take a look at this one here, bin ipconfig. One of the ideas that I had for PFS was that whenever we walk to an element, like say bin ipconfig, every single element in its path, like bin and ip, are going to be red. So the first directory, bin, is going to be red. The second directory, bin ip, is going to be red. This means that I am going to get the stats of all the files in that directory.
Right.
So my cache is going to update all of the stats of these files, and if any of them have a different QID or have been modified, it is going to invalidate those files. So the more you use your file system, the more updated it is going to be relative to your server.
Right, but as soon as you have received those, you don't know, they could be stale, right? I mean, as soon as you walk, then some other process could have modified the files.
Yes,
right?
PFS doesn't care about that. It's going to serve whatever it knows. It doesn't care about that level of consistency.
Okay.
As I said, it assumes that a user is a single person and he's going to be in one place in the world. He's not in multiple different places. So, and he's going to be interacting mostly with his user directory.
So it's not for like you're not expecting multiple users to be interacting with the file system.
Yes.
Or multiple processes.
Yes. I am expecting multiple different users to use the file system under the assumptions that I made.
Okay.
You know, that they have the directories that they are allowed to write. But even then, you know, as I said, PFS also assumes, let me go back a little bit, the file contentions problems still exist even without it. Like even if you were directly talking to the file server without PFS, you would still have the problems you're talking about.
Some of them, right.
Because when multiple people are working on the same set of files without coordination, you're going to get problems.
Well, no, I mean, but the problem that this introduces, or one that I can see, is if your local shadow tree gives you a response, and say like you walk to some file, and then as soon as you get the FID for it, then it gets deleted, and you walk again. On a local system, you wouldn't have the contention problem. You would just see that the file is not
Which
there.
is why the FID gets poisoned. So
right. So what happens between there? Whenever you're between the first walk and the poisoning,
the first
you
walk,
have a FID that's poisoned.
so every single operation that the client sends is going to be is still going to be sent to the server. It is not just dropped. We don't just reply it and drop. Okay, so we send it to the server. The server eventually sends back a response 100, 200 milliseconds later, and that response contradicts what PFS gave to the client.
And we're blocking until we get the response. Is that
No,
what
we're not. We just replied early.
Right. Exactly, but then we have a contention issue,
Yeah,
right?
exactly. I know. This is PFS knows that.
I think we put this, let's put a pin in this.
Okay.
Yeah.
I'm just confused. Thank
Yeah.
you. All right, thank you for going down
You're
the weeds
welcome.
with me.
You're welcome.
Yeah. So I've got a question.
Okay.
So actually kind of hammering on a different aspect of the contention, what might be interesting would be, and having a mechanism for basically PFSs to communicate with each other and say, hey, I'm claiming this subregion, and if you try to write to this or access it, if you try to access this, you have to go directly to the source and update yourself.
Yeah, that's something, and I didn't think about it. Yeah, thank you.
Yeah, I think so. As far as regional, one of the questions earlier, I think if you want to do something like Raft for Venti blocks, then that's right to get a bunch of consistent file servers as your regional servers. You could potentially do that.
Yeah.
But I'm wondering if there is a place for the mode flags to. Right now we have temp. We don't have anything that designates something as a device that it's like live data, don't try to cache it.
Yeah, we don't. Yeah.
Or if it's append only, go ahead and cache whatever you read before. It's not going to get overwritten type of a thing. So I'm wondering if, there's an opportunity for those types of flags to direct, whether you do it with CFS or PFS, basically, which blocks you cache.
Yeah, if we were to add new flags, it would certainly be new information that PFS could use and change its behavior. Certainly, yes.
Just a real quick one. You familiar with Time Warp OS at all?
Yeah, I thought about this problem as well, and I just ignore it.
I mean, specifically the concept of sending counter messages that cancel out previously received messages so that you can recalculate from a known good point.
Oh no, I just made something dumb, really. The thing is, I want you to build this first. I want you to test it. I want you to use it. I don't really want you to complicate it much more than that. It might not work, and if it doesn't, I might look into other things that I could do. Thank you.
All right, looks like that's it. Thank you very much.